Hey guys, welcome to your first video of new material. Today we are going to start our new unit. As you can see, we are going to focus on area. I'm going to try to keep it simple. The video is short because I know it's hard to watch a long video, so bear with me. But since this is new material, you should have paper in front of you. You should have your math notebook in front of you because there is going to be new vocabulary. There's going to be examples that I want you to pause the video and copy down so you have the correct work. Because the work you need, or the work that you're learning this year, is what is going to be expected of you the next couple of years in math until you graduate high school or if you go on to college. So I know you're not in the classroom right now, but you kind of still need to learn it to be successful in the future. So we're going to start by kind of talking about the difference between perimeter and area because I know that is a trouble spot for a lot of people. So when it comes to perimeter, I always like to think about a fence because a fence goes around the perimeter of the property. So the perimeter goes around the outside of a figure, whereas the area is what covers it inside. So I always like to think about the area inside a figure. So the area inside is what the actual area is. So there's the difference between area and perimeter, just to kind of do a little review. And then we have 4 vocabulary words that I want you to pause and write down the definitions of. So the first vocab word is area. So the area is the number of square units needed to cover a given surface. So I'm going to show you an example of that in 1 second. But so area is measured in square units. And that could be like a 1 inch by a 1 inch square. It could be a 1 foot by a 1 foot square. Any measurement that you want, but as long as it is a square unit. So a rectangle is actually a parallelogram with 4 right angles. If you look over here, I actually have an example on your screen for you. So a rectangle has 4 right angles. And if you don't remember what a right angle is, that's like the corner of a paper. It kind of makes like the 90-degree angle. So real quick, I want to jump down and talk about what a parallelogram is. So a parallelogram is a quadrilateral, which quad means 4. So a 4-sided shape with 2 pairs of parallel sides. So if you don't remember what parallel means, parallel just means lines that if they could go on forever and ever, they never cross. So if I'm looking at my rectangle, sides of pairs, 2 pairs of parallel sides. So this side right here and this side right here, those are parallel. If they extend forever, they would never touch. And then this side is parallel to this side. If they extend forever, they would never touch. The opposite of parallel, if lines intersect, that would be the opposite. They meet or they intersect. That is not parallel. That's the opposite of parallel. Okay, so nice geometry review for you there. So, and then a square is a rectangle with 4 congruent sides. So very similar to a rectangle, but instead of having different side lengths like rectangles do, the square has all 4 sides, and that should be a review. So when it comes to area and perimeter, if I look at this rectangle over here, this side here is 3 inches. So you can think of it separated into 3 inches, and then the bottom would be 4 inches. So when it's talking about areas being the square unit to cover it, what you want to think of is literally covering this surface in squares. I know that looks like a rectangle, but bear with me. This is a 1 inch by 1 inch square. Okay, so this is a squared inch or inches squared. So you want to think of area of how many squares is it going to take to cover this whole figure Obviously, they're a lot nicer on a grid, but just think of it as squares, and you can go and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square inches. So 12 square inches. Or you could write it 12 square inches or 12 inches squared. You see it written like that a couple different ways. So that is what like actually area is. I want you to think of squares versus perimeter being just the distance around the outside. You would add 3 plus 4 plus 3 plus 4 to find the perimeter. I'm not going to test you on perimeter because that is a 5th grade skill. We just do area in 6th grade. So I want you just thinking about square units covering a surface. So if I would give you shapes that are actually on a grid and I asked you to find the area, very simple. You could just go and count all of the square units that fill up the square or the rectangle over here. Just go and count all of them. Or you can use the formula, which I'm about to show you in 1 second. So I did attach, very quickly, I want to look at it. I did attach a formula sheet for you, and this is what it looks like. If, I would save this to your drive to access it. You can print it if you want, but if you want to just leave it on your computer, that is fine as well. I just leave mine on my computer and look at it too. But I try to color code it for you to show you what every variable or letter stands for in the formulas. So we're going to go over all of these shapes, and this is definitely a tool to keep in your tool belt. It'll help you throughout this whole unit. And back to our notes. Okay. So if you were to use the formula for square and rectangle, you know that you can do the length times the width, or the side times side for a square, and you should get the same answer. So 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units along the bottom. 1, 2, 3, 4, 5, 6, 7, 8 units along the side. So this is actually a square because it has the same dimensions on each side. So you could do side times side. So 8 times 8 is 64 square units to find the area. And if you went and counted all of them, you would also get 64. Same thing for a rectangle. You could do the length, 1, 2, 3, 4, 5. So this is 5 units times the width, 1, 2, 3, 4, 5, 6 units. So this is a rectangle. And 6 or 5 times 6 is 30. So the area of this should be 30 units squared. And if you went and counted all of them, it should give you 30. So you can do that either way when it's on the grid. So this is where I want you to, this is going to be where I show you the work for how you find area of figures. I would like you to just watch it through, watch me actually do the work, and then after every example, pause the video and copy down the correct work needed, because you do need to use this work going forward. So I give you the formula here for a square, and this is on your formula sheet as well. So the area of a square is side squared. So A stands for area and S equals the side length. So your side length here on your square is just 6 inches. So I like to go and write down everything that I know, or every value of a variable that I know. So in this situation, I don't know what the area is. That's what I'm going to solve for. But I do know my side length is 6. So S is actually 6. That way, I can go and plug everything into my equation or formula, because formula is kind of our equations, and then I'm going to solve whatever I can. So I don't know what the area is, so I'm going to leave it A. I do know that the side length is 6, so I'm going to plug 6 in for S and make that squared. So at this point, I'm hoping you know that 6 squared is actually 6 times 6. Therefore, the area of the square is 36 square inches. Okay, so I would pause it and copy that example down. Okay, so the next figure is going to be our area of a rectangle. So I have the formula here for you. A equals LW. So A is the area. The L is the length of the rectangle, and W is the width of the rectangle. So if you're looking at our rectangle here, the length is going to be 12, and our width is 5. So label or write down everything that you know. So A is what we're solving for, so I'm going to give it a question mark. The length we just figured out is 12, and the width is 5. Now I can plug everything into my formula that I know. So A is what we're solving for, so I'm going to leave it A. The length is 12. And notice how they're smushed together here. You should know that smushing two variables together means multiplication at this point. So we are doing 12 times 5. So I can do 12 times 5 is 60. So my area is 60. So it's 60 square inches, or 60 inches squared, however you want to say that. Okay, so I would pause it and write down that work as well. Okay, now I have some word problems. And these are very similar to the ones on your practice, just to give you like a heads up. So Square County is a square-shaped county divided into 16 equal-sized square districts. So we're talking about a square here. Bear with me. It's not going to be perfect, but I know that inside I have 16 square districts. Okay, so if the side length of each district is 4 miles, what is the area of Square County? So each one of these districts inside is a square, and I know that the side length is 4 miles. So I want to find the area of the square. So I want to bring out my formula. Area of a square is side squared. And I know my side length here is 4. So area, I don't know, but I do know my side length is 4. So plug in everything you know. I don't know A, so I'm going to leave it. I do know my side length is 4, so I'm going to do 4 squared. That's 4 times 4, which is 16. So I know that one district is 16 square miles, right? But if you notice, there are 16 districts inside this square. If one of them is 16 miles, so one district is 16 square miles, I need to figure out what 16 districts are. So in order to do that, I'm going to multiply 16 times 16. You may use a calculator for this. And you should get 256 square miles. So that tells me that Square County is 256 square miles. Okay. I would pause, copy down the notes that I took, rewatch it if you need to because you didn't understand it. Email me any questions that you have. But we have one more to do and then we are done for today's lesson. So Connie is building a garden in her backyard. She wants to plant each vegetable in a rectangle. Okay, so I'm going to draw my rectangle that measures 3 feet by 2 feet. So that just means the dimensions of my rectangle. So I can label it any way that I want. So 3 feet by 2 feet. If she has 12 vegetables that she wants to plant, how big does her garden need to be? So I know that this is 1 vegetable, the area of 1. So I need to figure out then how much area 12 vegetables would cover. So let's figure out how much area 1 covers at this point. So I'm talking about a rectangle, so we need to figure out our rectangle formula for area. On your formula sheet, it should say area equals length times width. So area, we don't know, that's what we're solving for. The length is 3. The width is 2. So we're going to plug everything we know in. So area equals 3 times 2. Our area is 6 square feet. So I always like to write it inside just to give myself a better idea. So 1 vegetable needs to be planted in a little spot in the garden that is 6 square feet. So 1 vegetable is 6 square feet. But I need to figure out how much 12 vegetables would be. So in order to do that, I take my 1 vegetable, which is 6, and I'm going to multiply it by 12. And I should get 72 square feet. So therefore, 12 vegetables would be 72 square feet. So that tells me that Connie's garden needs to be 72 square feet. Okay, so I would pause, write down your notes, rewatch it if you need to. So at this point, you do have a practice on a Google Doc that you'll just answer in your notebook. You'll check with the answer key. And then after you are done that, your participation 5 points would just be to do the formative online. If you do it, you get 5 points. If you decide not to do it, you do not get your 5 points for participation today. Please email me if you have any questions.